Hi, I'm Willow Chandarina, Product Manager with the Amazon Elastic File System team. I'm joined today by Jeff Tugas, Director of Software Engineering at Asurion. Today we're going to be talking about modernizing applications using AWS Lambda and Amazon EFS. We're going to start by talking about what we mean by modernization. So why would you do it? How would you get started? Then we're going to talk about how you would actually get started with modernizing your applications. So first, how to configure EFS for your Lambda application, and then how to configure your Lambda application for EFS. Then we're going to cover best practices. Then I'm going to hand it over to Jeff to tell you about his story with using these two together to modernize his application. Before I get started, I want to point out that we have a lot of sessions at this reInvent. I'd encourage you to check out the course catalog and look for other EFS sessions if you like this one. So let's get started with modernization basics, starting with why modernize an application using something like AWS Lambda. So the customers that I talk to that modernize their applications do so for three main benefits. First is to get increased agility and scalability of their application. And this comes from the fact that most applications are very spiky in their load. So they might go up or down based on time of day. As events happen, you would need to scale out quickly, and then after those events are over, scale back in. So it really benefits in having an application infrastructure that can support that spikiness and scale. Next, most companies that modernize their applications also modernize their development processes in the process. So they adopt things like continuous integration, continuous deployment. And in doing so, they can lower the time to market for new features and capabilities, making themselves more competitive in the market. And last, because as part of modernization, you're handing over more of the operations of your application and infrastructure to AWS, what you get is improved reliability of your applications. You get overall simplified operations and ultimately lower cost. Now, when you're modernizing your application with AWS, we have a suite of compute services that you can use to modernize your application. Everywhere from Amazon EC2, where you have the most control over what you're doing, but also you have the most operational work because you manage everything from the operating system up through your application, including integration with data sources, patching, orchestration, deployment, everything. As you go up the stack, you get to containers where AWS can take on your behalf some orchestration of your application and even some deployments with AWS Fargate. But at the extreme end of the spectrum, we have AWS Lambda. And with AWS Lambda, basically all you have to do is control your application code. The Lambda service handles the rest of it, from the orchestration, scaling, deployment, to integrations with other AWS services like Amazon EFS. And it's in this presentation today where we're going to be talking about how Lambda and EFS work together. There's another session at this reInvent about containers that I'd encourage you to check out if you're interested in that. So let's talk about what Amazon EFS is and how it fits into all of this. Amazon Elastic File System is simple, serverless, shared storage for your AWS applications. It's elastic, which means you never have to configure how much storage that you need in your file system. It grows as you add data, and it shrinks as you remove data, and you only pay for what you use. It's highly available and highly durable. Every time you write data to EFS, it is persisted to at least 3 availability zones in your region, and it's available from all availability zones in your region, which means you don't have to worry about where your application is. It always has access to your data. It's scalable to petabytes of data, tens of thousands of connections, gigabytes per second of throughput, and hundreds of thousands of IOPS. And it's cost optimized because we have 2 classes of storage, one optimized for performance, the other optimized for cost, and the ability to move data automatically between them based on a lifecycle policy. Now, when you take the properties and benefits of EFS and you combine it with Lambda, a lot of those benefits stack on top of each other and magnify. So for instance, the simplicity of these two services works really well together because both services are serverless. So when you have an application on Lambda with EFS, there is no physical infrastructure to manage. We've also done the integration in such a way that the configuration for your storage is inside your Lambda function definition, which means that developers can focus on just the storage needs of their service rather than the storage infrastructure that makes that happen. The availability and durability of these services work really well together because they're both regional services. So when you have a Lambda application, that application can run across multiple availability zones and not have to worry about where the data is because all of the EFS data is also available from all those availability zones. So now you can deploy regional applications. Both services are elastic, both in terms of compute scale up and down and storage scale up and down, and it can do that separately. So you can scale up your storage without having to add more data and vice versa. And last, we've integrated these ways in a way that's secure and simple to secure because we use IAM for access control, and we've added a feature called access points that makes it really easy to think about permissions. We're going to be talking more about those in just a bit. Now, when you modernize an existing app from using Lambda, often the way it looks is you have some code that is running on a physical host on premises or an EC2 instance, and that application is currently using external storage in the form of a storage area network or network attached storage. And when you want to modernize that application using Lambda, it's often as simple as moving your code over into the Lambda framework, but also you need storage because you're using storage with your existing application. So that's where Amazon Elastic File System fits in. It serves that external storage need that your code needs as you modernize your application. Now there's two key patterns that we see with customers that have modernized applications using Lambda. One is migration of whole existing apps from other places like on-premises servers or EC2 instances into Lambda functions. The other is app augmentation, or taking an existing app and adding some key new capability to it using a Lambda function, so adding a microservice to an existing application. So let me walk through some of the examples that we commonly see in both of these patterns. So first, an example of a common type of application to migrate into a Lambda function is a simple web or API server. So let's take, for example, an API server that is allowing users to get images from a repository and put new images in that repository. You would have a simple Lambda handler, which is handling those APIs, backed by a shared file system where those image files are actually stored. And in doing so, what you're able to achieve is an application that instantly scales based on demand at the Lambda side, while having each of those concurrent invocations sharing the same data in the file system. So it makes it really easy to create this type of application. And anytime a new image is put in, it's strongly consistent, meaning it's available from all of the other concurrent Lambda functions. And you can do all of this without actually managing any infrastructure. Another use case is, we'll call it batch simulations, but it's really any batch process that you might want to migrate from an existing HPC type environment into Lambda. Because now for the first time, you're able to actually have shared data between each of your Lambda functions and unlimited data available to those functions. So the benefit of this is you can instantly scale up parallel processing and pay for only the execution time that your job takes to run. So basically the way this would work is you upload some shared data, some reference data to your file system, kick off your job, which scales out your Lambda functions. It chews on that data, returns a result, and you're done. Now let's talk about some augmentation use cases. So a very common one we see is machine learning inference. So you want to add some intelligence to your application by taking in new data and returning predictions or personalizations or classifications. Now to do this, what you need to do in your Lambda function is give it access to library files like XGBoost or TensorFlow, and machine learning model files. And oftentimes the size of those files can be larger than the amount of data that you can fit in your Lambda definition, your layers, or even your temp space. So for that, you can put all of those assets in EFS and then scale out your Lambda functions around those shared files. And in doing so, you can do inference, but not only that, you can do it with large model files, large libraries, and ultimately you can achieve pay per use ML inference using Lambda. And the last one that I'll mention is augmentation of data processing. So a common one we see is current applications that accept uploads from users often want to trigger virus scanning on that new data. And instead of adding the virus scanning capability into their existing application, they want to build it outside as a microservice, and Lambda lends itself really well for that. If only you can share data between that new microservice that you build in Lambda and your existing application. So EFS becomes that bridge between the two and allows you to do data processing in Lambda. So now that we've walked through some of the use cases and motivation, let's talk about how to get started and do this. Starting with how to make sure that you do this in a secure way. So typically, when you set up EFS for your application, there's two key goals that you have. The first goal is the file system that you create should only be available from the applications that need it, not the applications that don't. Next, you want to make sure that if you're sharing a file system between multiple applications, those applications only have access to the specific data, the files and directories that those applications need. Now we're able to achieve both of these, and I'll show you how. First, to ensure that you have access to your file systems only from the applications that need it, you can use IAM, Identity and Access Management, to define policies of which applications can connect to your file system. Now, the way this works is each of your Lambda functions has what's called an execution role. And that execution role is the one that's used for file system authorization. And you can control the authorization policy in one of two places. One is you can attach an identity policy to the role itself that says which specific file systems it's allowed to connect to and what it's allowed to do on those file systems. Alternatively, or in addition, you can use a resource policy that's attached to the file system to control which roles are allowed to access that file system and what they're allowed to do. Now, when you use IAM to control access to your file system, you can get granular with it by using a couple of different actions in your policy. First, you can use the client mount action. With client mount, what your application is able to do is mount the file system. It's allowed to read data, but it's not allowed to write data. So this is a good action to use if you have an ML inference or other Lambda function that is only reading data from your file system. If you'd like your Lambda to write data, then you can add another permission to it, which is the client write permission. So with the client write permission, you can mount your file system, you can read, and you can also write. Now, for the second goal of how to make sure that the applications that access the file system do so and only have access to the files and directories that you want, we should understand how file and directory permissions work and how it maps to identity. So for this, let's use an example of an existing file system, and in that file system there's three directories. One directory is called Bob Home, the other is called Maria Home, and the other is called BI Shared. Bob Home is owned by user Bob, Maria Home is owned by user Maria, and BI Shared is owned by group BI users. And now we're attaching a Lambda function to that file system. Now, the thing to understand is when you attach a Lambda function to a file system, the identity of that Lambda function is going to be unknown because in Lambda there is no actual concept of a user ID or a group ID like there would be with a traditional NFS client. So in that case, unless we do something, there's no way to guarantee that your Lambda function has access to the directory it needs. And it's that property that led us to introduce a feature called EFS access points. Now, to understand EFS access points, let me first show you one and then walk through what's in it. So this access point has a name, it's associated with a file system, and it has two key things that you configure. First is you configure an object called POSIX user. Now this is where you define what the user and group is for the application that's connecting through this. So in the earlier example where we had a Bob home and a Maria home that were owned by user Bob, user Maria, this is where you can say whether the application connecting is going to act as Bob, or whether it's going to act as Maria, or whether it's going to act as some group by defining the user ID and group ID here. The other thing you can do with an access point is map your application into a subdirectory of your file system. So by default, all applications connect to the root of the file system, which means they can navigate wherever they want. By using a root directory, you can have a private spot for your application within the file system where it won't see any of the other private spots for the other applications that are sharing that file system. And further, you can use creation info within this to automatically create that directory the first time your application connects with the permissions that you need to access it. So there's two key benefits in using an access point. One is it enforces a file system identity. And more than that, with Lambda, it gives your function an identity that's meaningful to the data in your file system. So now you can make sense of file and directory ownership without having to associate user ID directly with your Lambda function. Next is it can create those private directories for your application and help you share file systems between multiple applications. And the way access points work is you connect your application to your file system through your access point. And when your application reads and writes data, it can be reading and writing with any user ID that it tries to, or it could, or whatever Lambda happens to assign internally. But the access point maps it to what you had configured. So in this case, all of the actual file system access is going to happen as user ID 123, and that's what you would map to the different permissions in your file system. Now you might be wondering, how do I make sure that my particular application is only authorized to use a particular identity or access point on my file system and not another? And you can use IAM for that as well. So there is a condition key that you can associate with your policies that maps a access point ID to a particular role. And that's how you can ensure that this role can get this identity on this file system while this role cannot. Now let's get started with actually connecting your file system to your Lambda function. This is pretty easy. So the first step is to create your file system. So you can go to the EFS console, click Create, New File System, select the defaults. We'll pick intelligent defaults for you and create mount targets. And then you'll want to go into that file system and create an access point. Next thing you'll do is configure your function for VPC, because it's over the VPC that your function connects to your file system. And then you will go into the EFS configuration of your Lambda function and configure which function or which file system are you connecting to and with which access points. And then if your task role matches that of your policy, then the connection will be successful. So let's talk through some of these best practices. So best practices for security are enable encryption at rest. It's on by default if you use the quick create utility. There's no performance penalty and there's no cost, so there's really no reason not to set up encryption at rest for your file system. Use EFS access points. In fact, it's the default for Lambda. And in doing so, make sure that you configure a actual UID and GID. Don't leave it blank, because then it will try to do all operations as root. Enable encryption in motion. So again, this is the default in Lambda, but if you're accessing that file system from outside, it's worth turning on just to make sure that everything is encrypted. And use IAM authorization. So you can also try using security groups for limiting access to your file system, but it gets hard to manage when you're not sure which IP addresses your Lambda function is going to be showing up as. With IAM, you can know ahead of time whether a particular application is going to be authorized for your file system. So on the performance side, we've been making several improvements to performance this year. We announced a 400% increase in read IOPS for EFS file systems in general purpose mode. We increased the per client throughput by double, or 100% to 500 megabytes per second. So the best practices here are, in most cases, you're going to want to use a general purpose mode file system. The only exception to this is if you think you're going to need super high concurrency and all of your Lambda invocations are going to be getting at different files in different directories and really spreading that load. In that case, max IO might be faster, but it's always better to start with general purpose first. Next, configure provision throughput for your functions to make sure that you always have the throughput you need for your application. In EFS, the amount of throughput you have on your file system by default is based on the amount of data that you have stored. So if you aren't storing a lot of data yet, you may not have the throughput your application needs. If you start by configuring provision throughput, as your data grows, eventually you may no longer use that provision throughput because we'll always give you the higher of the two, whether it's the amount you provision or the amount you're entitled to with the amount of data stored. But provision throughput gives you the insurance policy of always knowing that you have the minimum. And last, make sure you're monitoring your throughput using CloudWatch, and you can even do this in the EFS console. Now, some Lambda-specific performance considerations. The big one is your file system has an amount of throughput associated with it, and that amount of throughput is shared among all of the concurrent Lambda functions. So if you have a concurrency of 100 and all 100 of those functions are downloading a file, each one's going to be downloading at 1/100th of your total file system throughput. So make sure you think ahead of time on how much concurrency you think you're going to need and how much throughput you need to drive that concurrency. Now, there's a difference between Lambda cold starts and warm starts. So many of you know this already if you use Lambda already, but cold starts what happens when a request comes in and there's no Lambda containers available to serve that request. Cold starts take a little bit longer to come up, but then they're able to serve warm starts, which are what happens when a request comes in and there's already a warm container ready to take that request. Now, the importance of both of these are, with Lambda, there is a client-side cache that stores any data that you've already downloaded from EFS. And that cache can be your friend. So take, for example, a machine learning inference use case where there's a shared model file between all of your Lambda functions. You only need to download that model file during your cold starts. And as long as that model file doesn't change, every time a subsequent warm start happens, that model will be pulled out of cache and you don't need to download it again. So the total amount of throughput you need in your file system really is a matter of how many cold starts you think you're going to be doing at a time. So if your cold starts ramp up and then you have warm containers, you're going to go really fast for those next round of requests that come in. Now, if you're doing batch jobs, there's a trade-off between concurrency and overall performance for the same behavior because of the caching. So experiment with different levels of concurrency and see what gives you the best overall performance for your batch job. Now, some other recommendations generally. So to get the best cost for your file system, make sure you enable EFS infrequent access. When you enable EFS infrequent access, we are going to automatically move data from EFS standard to EFS infrequent access and save 92% of the cost on that data. And we only move data after you have not read or written it for your lifecycle policy. So generally, if you haven't read it by that amount of time, you're not going to frequently need it again, and you're going to get the best blended cost for your file system. Most customers that turn this on achieve a blended price of 8 cents per gigabyte month or less. Next, make sure you're backing up your file system. It's really easy to do so using the AWS Backup service. You can simply configure a backup policy that takes a backup every day and saves it for a week, takes a backup every week, saves it for a month, and you always have you're able to rest knowing that if a file accidentally gets deleted, you can pull it right back in and pick up right where you left off. So now what I'd like to do is hand it over to Jeff to talk about the experience that he's had at Asurion using AWS Lambda and Elastic File System together?
Yeah, thanks, Will. So as you mentioned, Jeff Tugas, Director of Software Engineering over here at Shurion within our Enterprise Data Services team. Shurion is a technology company. We help people get the most out of their devices. We offer insurance plans for getting replacements on your phone if you break or lose your iPhone or what have you, or also on televisions and those kinds of things. We also have a lot of tech support, different offerings, including messaging and phone support. And generally, we enable people to get the most out of their tech. And why I'm here talking to you today is this quote here: "Your call may be recorded for training purposes." We've all heard this before, right? Well, I've recently been involved in a project that really is putting this, putting this to practice. And we have a pretty massive call center operation within Shurion, and there's a lot of priority on making that as efficient as possible, but also creating the best possible customer experience for users who are calling in to our experts and trying to get help. So we put a lot of priority on on auditing how the experts are handling calls and making sure that they're basically giving the customers like the best possible experience that they can. And recently we've decided to take this to the next level and automate how we are actually monitoring and grading call quality and providing real-time coaching to experts as they're actually talking to customers. And we did this using AWS Lambda to run a series of machine learning models that grade and analyze calls in real time. And specifically, we had one model that we needed a lot of files, file storage for, and EFS came in just in time to save the day and enabled that. So that's what I'm going to talk to you about here. So a little background: we've got this system that we call our machine learning pipeline. Really, it's just an event-driven ML model execution platform. It's all AWS based, all serverless. It's using SNS and SQS and Lambdas. There's lots of Lambdas within it, kind of orchestrating, getting events from a number of different sources within our overall telephony system and call center operations. And depending on what the data is that this pipeline receives, it has dozens of machine learning models that are actually being run within Lambdas that it executes and provides the output downstream for reporting and analysis purposes. And recently, one of the models that we wanted to introduce was going to actually do analysis on the call recording itself, which is a WAV file. And we had this process, this program for the machine learning model already built out before we decided to try putting it in Lambda. It's fairly complicated. It's using FFmpeg to do transcoding, convert the WAV file to a different format. It's got a few other pieces within it. And we were looking at this and we thought, well, Lambda's got custom, the custom runtime feature and a bunch of other stuff. Maybe we can package this up within Lambda and just fire and forget and not have to deal with the operational overhead of running real servers, right? And so we started down this path, and we quickly ran into some interesting challenges with some of these machine learning workloads. Oftentimes, some of the libraries are pretty huge. We started having challenges with getting all of the dependencies packaged up within the Lambda size limits for the package itself. We eventually worked through that by doing some creative stuff, double zipping some of the dependencies and so on. But then the next challenge we ran into came to the actual temporary disk space that Lambda provided out of the box, which prior to EFS, you were limited to 512 megabytes. And we were getting seriously really creative and trying to make the most of this 512 megs. But we found that there were a couple of cases in our upper quartile of call length, over hour-long calls. The file size would be large enough that as this Lambda was processing that file and creating additional temporary files as it was analyzing and so on, we would exceed the 512 megabyte limit. So we were just about ready to throw in the towel on the Lambda approach and go with a more traditional, EC2 based approach when EFS for Lambda was announced. And I discovered this, and literally within a day, I had gone and basically wired up EFS to our Lambda with basically no change to the code other than just pointing to a different file system location, since EFS is seamless from the Lambda's perspective. We had, KMS encryption set up for, encryption at rest, and we had access to the EFS volume all locked down as well I described. So it's, nice and secure. And we were able to get this Lambda running and deployed into our machine learning pipeline for continuing to make our call center operations and customer experience ever better. So, yeah, and that's my story with Lambda and EFS. It was really cool and fun experience. So I'll hand it back to Will now.
Thanks, Jeff. It's been a pleasure working with you and seeing all the exciting things that you've been able to do with this over at Asurion. So before we wrap up, I want to point again to the fact that we have a ton of EFS sessions at this reInvent. If you like this session, some others that you might be interested in seeing are the EFS Deep Dive, Modernizing Applications with Containers, and best practices for both security and performance. I thank you again for joining us with this reInvent session and hope you enjoy the rest of your show.